Okay, so welcome back to Unit 3, Gravity and Circular Motion. So the first two videos here, we focused on gravity and universal gravitation. Now we're going to start talking about centripetal acceleration in this video, and then we're going to work our way towards what is known as uniform circular motion. Okay, so centripetal acceleration. So this is a term that gets thrown around. Sometimes students or people want to change the pedal part to fugal, okay? But that's not the force the acceleration that we're looking at. We're looking at centripetal, okay? Now, if you drive a car on a circular track, the direction of the motion changes continuously, right? Your velocity remains constant, right? But remember, velocity is a vector, which means, let me put it this way, not our velocity, right? But our speed remains constant. But our velocity changes, right? Why does it change? Because we're continually changing the direction, right, of the car. Therefore, we're changing direction. We must be accelerating. So the acceleration that we're focusing on here is an acceleration directed toward the center of a circle, okay, that we know as centripetal acceleration. Now, centripetal literally means center seeking. Right? And so that's what this is. It's a center seeking acceleration, which means it always points to the center of the circle. Okay. Now, if we need to find the speed, right, of an object in circular motion or while it's experiencing centripetal acceleration, we're going to use the equation. We are going to use the equation velocity equals speed equals distance over time. But if I'm going in a circle, the distance that I travel is the circumference of the circle in that set time, okay? So the numerator here is the circumference. Even if you do like a quarter circle, a half circle, right, your velocity is still related back to that circumference, or your speed is still related back to that circumference, okay? And this is the time to travel, right? That circumference. So if I have a 1 meter radius circle, well, I do 2 pi r, which is going to be 2 pi, right? So 6.28. And if I do that in 1 second, that means I have a velocity of 6.28 meters per second as I travel in that circle, okay? Now, to find the centripetal acceleration, what am I being accelerated at? The equation is simply a sub c equals v squared, right, over r. Right, and so let's look at some little like pictures here. So one thing to always note, right? They put it in yellow, but I always like to attach it to the inside of the circle. So you'll see our AC and here's our V, right? So something to note is that V, so the speed, right, that you go around the circle in, and the centripetal acceleration, they're perpendicular to each other. Okay, regardless if it's a car going around a turn or if it's a centrifuge, right? And this is where people want to use that centrifugal word, right? And so we have, right? So there's your velocity, right? Heading perpendicular to the circle. Acceleration pointing into the circle, remember, is a center seeking acceleration. Okay. Now, here's a quick little like example, right? Quick little conceptual example. So we got this hockey puck attached to a string. It's going in a circle, right? It's traveling in a circle in this manner, right? Which means my velocity is here. My centripetal acceleration is along, right? That's that radius, right? So this is my AC. This is my V. Now the question is, if the string breaks at position D, right, or where D is here, or at this point here, which direction is it going to travel? Okay, if you want to take a pause real quick to kind of think about it. Okay, so the answer is B, right? Because remember, it's traveling in the path, and once that string breaks, it's going to follow the path at which way it wants to go. Remember that whole idea of inertia? So it's going to want to keep going in that path. It doesn't want to move in the circle because now it's free of any centripetal acceleration. So it's going to travel perpendicular to the circle that it would keep moving in, right? And again, that points in the direction of the velocity, okay? Now, let's look at an example using these equations, right? Here's a great real-world application of this, okay? So here we have a ball attached to a string that is 1.5 meters long. It is spun so that it completes 2 full rotations every second. So what is the centripetal acceleration felt by the ball, right? So here we are. Here's our hand. Here's the ball, right? And so we're going to travel, right, 2 full rotations every second. So we're going to do 2 circumferences every second, right? Or you can think about you're going to do 1 circumference every half a second, okay? So the first thing we need to do is find what is the speed, right, in that time, right? We're still going to do distance over time, but what I actually need to do here, sorry I blanked the screen. What I actually need to do here is I'm going to erase that real quick because I'm going to do 2 circumferences, right, in that time frame. Okay, so it's like I'm going to do 4 pi r in my time frame, right? And this 2 is because it tells me right here I do 2 full rotations, right, every second. So now I'm going to plug in my numbers. I'm going to say 4 pi, the radius of my string divided by my time. And you do have to be careful because sometimes they'll give you the diameter. We know this is a radius, right? Because when they say a ball is attached to a string that is 1.5 meters long, well, that's, if I let that kind of fully go out, that's going to be the length of the string is going to be the radius of the circle it makes. So what I really have here is, right, 6 pi, which is approximately 18.84 meters per second. So that's going to be my speed. Now, I need that because if you remember the equation for AC, its centripetal acceleration is v squared over r. And so that 18.4 is going to get plugged in right there for my velocity or for my speed. So I'm going to do 18.84 squared. Now, don't forget to square it, right? Because sometimes students will forget to square that number. And then divide it by 1.5, and that'll give me the centripetal acceleration, right, of this string or of this ball. Okay, and so you get an acceleration of 236 meters per second squared. Okay, they call these bolos or bolas, right? And so this is, very skilled. This is a very advanced or a very skilled weapon to use, right, in hunting and in war. Okay, so now, I apologize, I jumped ahead. Now, because we have an acceleration associated with this, we will have a force that is associated with this centripetal acceleration as well. And all these objects, when undergoing centripetal acceleration, will experience what we call the centripetal force, which is going to be the next